So welcome for today's lesson, Thrives Achievers Biochemistry lesson by Thrives Tutor. So what is our today's lesson? So today's lesson is the introduction to biochemistry, which is tutorial sheet number 1. We'll try to answer which are the information which you found in lecture 1, even in lecture 2. We'll answer them in this tutorial sheet. So let's start with the first question. So the first question is, a scientist finds systolic H positive of 3.16 times 10 to the power negative 4. Would a physiological buffer be required to set in at this pH? So what is the pH? So pH, we determine that it has what? Acidic and also basic, right? So here they say 3.16 times 10 negative 4. So we'll find this we'll find what? We'll find the pH. We have given the atom of this concentration 3.16 times 10 to the power negative 4. So how can you find the pH? So the solution, there they say a buffer. So we'll find first the pH. Now to find the pH, we need to know if the buffer will be used to that pH, because what is a buffer? So a buffer it maintains what? The pH. If we found that the pH is normal, then the buffer will not be used. The physiological buffer will not be required. If it's not normal, then physiological buffer will be what? Will be used. So the formula for pH is negative log H positive, right? So we'll just plug there. We'll find what? Negative log 3.16 times 10 to the power negative 4. The pH is 3.5. Now the question was, would the physiological buffer be required at this pH? Yes, indeed. Because the pH is what? 3.5. What is the normal range of the pH? The normal range is 7.35 to 7.45. So that is the normal range. So indeed the physiological, it requires, so that 3.5, the buffer which maintains the normal range of the pH. So 3.5 to 7.35, in between to 7.445. Let's go to question 2. Name the important physiological buffer that would balance the acidic, the best appropriate in this case. So which buffer should required in this question? So we have 3 types of buffers. I'll explain them, or 4 types of buffers. I'll explain them. Yes, in the lecture slide they just include 3, but I'll explain those 4 types of buffer. So here the question is, they gave us a scientist to find cytosolic. So which buffer is responsible to maintain pH in the cytoplasm? Cytosolic means cytoplasm, or cytosol, which is cytoplasm. Which specific buffer? So the specific buffer, it is the phosphate buffer. So this system requires a dominant chemical buffer working inside the cytosol of the cell, or the cytoplasm of the cell. This buffer, that's the answer, is a phosphate buffer. The clue was E, cytosolic. That was the clue. Now question C, let's explain other buffers which we just need to know. What other physiological buffer are important in the body, and what is the specific role of each one? So the first one, which is bicarbonate buffer. Bicarbonate, it maintains the pH in the blood, especially the kidney and lungs. Yes, so this is bicarbonate buffer. It's important. Protein buffer is to maintain the pH, especially in cells. Then hemoglobin buffer is to maintain pH in the red blood cell. We can even rate hemoglobin, which is found in the red blood cell. So this is simple. Yes. Then we move to question 2. So that's all which we just need to know on buffers. Let's go on question 2. So question 2, they said a patient with acute diarrhea has blood pH of 7.03 and a CO2 of 1.10 moles. What is the concentration of bicarbonate? Use the information given below. So the question here has this. That's the question which they have given us. A patient with acute diarrhea has blood pH 7.03, right? Which the pH of this blood is less, because the normal, they said they give us this, the normal pH, which is 7.35 to 7.45. That's the normal pH, those normal values. Now, even the concentration of CO2, we know the partial pressure for concentration is this, right? 4.5 or 6.1 partial pressure, right? Now it's less than, so this one, it is what we're saying, it is in acid. So this, it is in acid, 1.10, it's an acid. So that's the reason why we identify when we want to define the bicarbonate. So bicarbonate, is it an acid or a base? So bicarbonate, it is the base, right? You put on base, because carbon dioxide, they say pH 7.03, which is, this is an acid, right? 1.101, which is also an acid. So 1.0 will just replace E 1.0. Want to find the base, which is this bicarbonate. But then pK, they have given us pK is equal to what? 6.1 at 37 degrees. So just put 6.1 here. Even the pH they have given us 7.03. But then you want to find what? We find the base. So just replace everything here which you have, then you find the base. So the solution, the same thing which I was explaining, we use this formula, then we just replace, have replaced everything here. We can see 7.3, 6.1 log per, even here 7.3. So this side, say 6.1 will go this side. Yes, so this is simple. We replace, it's giving us 0.93, then log here. So here it's simple also. Those who know logs, me right here, so that I'll help you. Okay, so here this is simple, right? So we have 0.93. So here we just introduce what? A log. When we introduce a log, so that the log should cancel itself, it should have a base 10, because log the base 10, it will cancel itself. So this one is base 10. Even here, if you raise by power, so it will be 0. What? 0.993. If we put a log here, so because this is cancelled, they can be cancelled itself here. When it's cancelled, we are remaining with 0.93 here. That's the reason we have put log 10. It will be cancelled, it will cancel itself, it's giving us 1, so that it's given 0.93 here. Yes, so this is, don't be confused. So just write equals. Want to know how we can handle this log, so just put even here log here, log here, the same thing. So it will give you what? Negative a over what? 1.110. Then log will go. Don't be confused. Log will go. Even a log will go. Then we are going to remain with 10 to the power 0.993. 10 to the power 0.93. So this is simple. Even here, that's what we would remain with a negative with the concentration. Then we'll remain with 1.10. Then you can just cross multiply. We use a calculator, you cross multiply like this, then you find the solution. A concentration of this will give you what? So what is the answer? So what will be the answer? So 9.9 3 what? 36. So that is the answer. Millimoles per what? Per liter. So that is the answer here. So this is simple. So the thing which I was saying, that's the same thing. Yes. So the same thing here, that's what we just need to do. So that's the same thing here which we did here. So indeed it's simple. Like this. So let's move. So let's move. So question what? Question B. Make a diagnosis if you find this 9.36. So this is bicarbonate, right? So this bicarbonate 9.36. So bicarbonate is where this one, right? That's a bicarbonate. It's 22 to 26. So if it's less than, it's what are we calling? Less than this. So the answer was metabolic alkalosis. The bicarbonate is less than normal, which is 24, or which is, so the normal, which is 22 here. So it's less than, that's why I say metabolic alkalosis. I'll explain this more. Even here, the lactic acidosis. Question C, it says, what are the most common cause of this condition? Which is lactic acidosis, diabetes, ketoacidosis. Yes. So this question is simple, right? They have said here, make a diagnosis. So I'll explain this. I'll explain this in question 3. Yes. So that you can understand. Let me explain this. How can we make a diagnosis? If they have given you 7.49, 40, even 7.3, right? Let's make a diagnosis. I explain this so that even question this, making a diagnosis, if they have given you 7.36 moles, how can you make a diagnosis? So this question is, interpret the following acid-base balance. So what you just need to know is this. So the things which you just need to know is this. So take note. I'll write here. So if here I'll write pH, it's an acid which is would direct as I'll write here. So pH is 7.35, right? 7.35 to 7.445, so that you will not be confused. So this side, this side, it is an acid. We know pH, if it's less than, it is what? An acid. Then this side, it is what? A base or alkaline, right? A base or alkaline. Okay. A base or alkaline is the same thing. Or alkaline, I'll just write alkaline here. Alkaline condition. Alkaline condition like this. Okay. This is alkaline, right? Because it's more than 7.4. So this is the normal range of the pH. So this is the normal range of the pH. Then we're making a diagnosis. We go to partial pressure. So this is a pH, right? A pH. Partial pressure, will go to partial pressure of this, so that it will be easier for you when you start even answering the question. It will be easier for you. So here it will be what? Partial pressure of CO2. So it will be easier for you. We know it's 4.5. We write 4.5 to what? 6.5. 6.1. That's the partial pressure, right? So similarly, what you are saying now, this side is acid, which is acidosis. I'll just put acidosis. They call it acidosis because it's acid, right? To call it acidosis. This side it's alkaline, we say it's alkalosis. So we say this is what alkalosis. So diagnosis it will help you to diagnose. Now this partial pressure for carbon dioxide, it's respiratory. We know oxygen and carbon dioxide deals with what? Respiration, right? So which is respiratory. Respiratory, right? Respiratory. Now we go to this, which is bicarbonate. So I want to write everything so that it will be easy for you even to answer any question which you encounter. So you write the range. So write the range. So the range is what? So let's write the range. Okay. So this is 26. This side is 26. I'm just getting this value. So you just need to know those values. In case they haven't given you, you just need to know them. Because this is simple. Okay. Write like this so that it will help you to diagnose. So this side it's opposite. This side it's what we are calling what? Alkalosis. For bicarbonate. This side is what we are calling what? Acidosis. So acidosis. So this side is acidosis, this is alkalosis. Then this one it's metabolic. For bicarbonate it deals with metabolic. Okay. Metabolic. Okay. Write metabolic. So if you write everything like this, any question which they give you here to diagnose it will be simple. So which will help us, it is determine the pH. So the pH will be our goal here. It will determine if it's an acid or base. Then we'll follow this diagnosis. So we'll start with 7.49. So the pH is 7.35 to 7.45. So here it's what? A base or what? Alkalosis, right? So here the pH is this side, so it's in alkalosis. Then you go to this one, 7.35, the partial pressure for carbon dioxide, right? So partial pressure for carbon dioxide, it is 7.3. So 7.3 is here, so it's acidosis. Wow, the pH showed the pH is 7. It's more than so it say it's alkalosis, but this side is showing acidosis. So this diagnosis will be invalid. Will not use this because the pH is telling us it's alkalosis. Then this one is telling us 7.3. It's telling what? 7.3 is what? It's acid, right? 7.3 it's an acid. 7.3 is an acid because the number is 7.35. So 7.3 is an acid, but here it's saying that the pH is telling us. Oh, sorry. So sorry. Let's repeat again. So here we have diagnosed everything here. We'll get this value which is 7.49. 7.49, we know 7.49 is giving us what? A base or alkaline, right? 7.49. So it's giving us E. This is where it's ending. Then partial pressure for carbon dioxide 7.3. Partial pressure for carbon dioxide 7.5. It's giving us what? An acidosis. So it's giving us E. So this will be invalid because the pH is saying alkaline. Now the E is saying acidosis. So we'll not say it's respiratory acidosis. Let's check this, which is 40. The bicarbonate here, it's saying 40. So more than 26, it's what? Alkalosis. So it's giving us E, which is alkalosis. So the correct diagnosis, it should be metabolic alkalosis, because the pH also is more than E, saying it's an alkaline, right? So the correct E, it's metabolic alkalosis. So that's it's metabolic alkalosis. Then you go to this question, right? So the same thing, this is easy. As long as you have written that, then everything is easy. 7.24 to 9.3, 26. Okay. So you go to diagonalize. 7.24, 7.24 here. So it's less than, the pH is less than here. So it is an acid, right? Let's go to 9.3. We say 9.3 is where? It's an acidosis, right? So it's 9.3 from partial pressure. It is acidosis. So here it's correct, right? Respiratory acidosis, because the pH is in acid form. Even respiratory acidosis here, right here. Now here for metabolic, it's 29. It's saying it's alkalosis, metabolic alkalosis. So this one will be invalid. Yeah, so this one will be invalid because the pH itself is going this side, which is respiratory what? Acidosis, because this pH is in an acid form. So similar thing, I'll just do this, the last one. 7.54, 54, which is here, the pH is in alkalosis. Then 3.2, it is what? 3.2 is alkalosis. So just direct, it's giving us what? Respiratory alkalosis. So this is simple. So that's how we diagonalize. We just be comparing like this. So it's simple, yes, but they will not give you where both two they are giving you the same respiratory acidosis, metabolic acidosis. No, they'll give you one, but they can give you two, but you can just say both questions they are correct. So this is simple. So you try to answer these two questions. If you try to answer this question, you can inbox me on WhatsApp. This one 0973 17 81 00. I'll mark you. Yes, when you inbox me on this line, I'll mark you. Yes. So this is simple. I'll mark you. You try to answer this, you inbox me, I'll mark you. So the question 4, the last question was, what are the common causes of metabolic alkalosis? So what are the common causes? Which is vomiting, renal loss, e.g. diabetes, nasogastric suction. So those are the causes. We will explain more when we start learning on acidosis, alkalosis. Yes, so those are the things which you just need to know. So search more on more causes, especially metabolic alkalosis, metabolic acidosis. You search more the causes. So we end here for today's lesson.